Thank you so much, Marty, for being here. And thank you all for joining us.
For those of you who have not met Marty previously or taken his classes, he's got a couple classes in the Mastermind. One is his class on tire walls, and the other is he did a class on thermal performance. So I met Marty, I don't know, 12, 14, 16, stop me any years ago, Marty, I don't know, one long time ago when I was at Earthship Biotexture, and he did a thermal study of many different types of alternative homes and came to Taos and put probes in an Earthship and temperature probes. Marty, if I'm messing up scientifically how you're supposed to say
No,
that,
you're doing well.
that measured the ambient temperature inside the space, measured the temperature in the greenhouse buffer zone, and measured the outside temperature. And he was able to come up with graphs over a month period of time, showing the thermal stability of this passive solar rammed earth building. And since then, he's done a lot of trainings and builds in Australia. He built the Earthship that he's in now, which I believe is also available on Airbnb, and you can find a ton of interviews with him all over YouTube. And he also did a structural analysis of rammed earth tire walls for, was that just for seismic or just structure in general, Marty?
It was both.
Okay, yeah. And
Yeah.
so he's the science, we get scientific information about cool stuff from Marty.
Thank you, Kirsten. That was a wonderful introduction. All right. Well, perhaps the first thing to say is here in Australia we call your wildfires bushfires. So yeah, we're talking about the same thing. And maybe one other little important difference between here in Australia in the Southern Hemisphere and Northern Hemisphere America is just the whole thing of which way to face a passive solar building like an Earthship. So here in the Southern Hemisphere in Australia, we face our homes north, whereas it's the opposite, you guys face south. So let's just get that clear from the beginning, because when I say north, you're probably gonna need to change that around and think south. But yeah, I'm actually not gonna talk a lot today about sort of what is an Earthship or a passive solar home. I'm sort of gonna try and focus more on the bushfire resilience aspect, but I will be showing lots of photos of Earthships, because sort of part of my conclusion to this presentation is that Earthships are inherently really bushfire resilient, and I'll explain why as we go along. Let's go. So this is an image, satellite image of, it's actually a composite image, so it's a bunch of satellite images showing Australia over a 1 month period. This is the end of 2019. And you can see that throughout that month, there were some big bushfires burning in Australia. And then there's a similar photo, recent one, of the wildfires in California. So I just thought it would be good to start off with yeah, just sort of seeing the extent, and yeah, I think it's my sort of belief and understanding that we just have to expect more bushfires in the future because of the way our climate is changing. And so there's a quick definition here of an Earthship. It's a home that's self-sufficient, resilient, and sustainable throughout its whole life cycle. And so by life cycle, I mean construction, occupancy or use, and demolition. And these are particularly that last phase there, demolition. And I guess, you know, in terms of bushfires, it could be a bushfire or wildfire that demolishes your home. And kind of one of the cool things about Earthships is that even at that demolition stage, the materials can be either just sort of go back into the earth or be recycled, and maybe be used to build another Earthship or another type of home, or get recycled into some kind of a product. And so this is an Earthship in Australia. I'll show some more photos of this later, but yeah, just sort of quick recap. These are the 6 Earthship principles, and here are the sort of challenges facing us in the future. One of which is bushfires, and so it's really this idea of being self-sufficient, and also this idea of resilience that enables the occupants of a home like this to sort of ride out or defend, or not be affected as much by some of these things there highlighted in the red. Again, these are just things that are probably part of our future, and it's wise to get ready for these eventualities. Okay, so bushfire resilience. The Earthship is a type of earth-sheltered or earth-covered home, which are well renowned for their bushfire resilience. So there's an architect and researcher in Australia who's written a book called Australian Earth-Covered Buildings, and that documents a whole bunch of these underground houses in Australia. The whole field of underground or earth-covered buildings got really popular kind of back in the 70s, when there was an energy crisis, and some people were trying to think, how can we build really energy efficient homes? And one way was to go underground, because underground homes really have lovely stable indoor temperatures, and they're inherently bushfire resilient because of all the earth around and on top of them. Yeah, there's sort of a little anecdote here from the Eco Specifier website, which is actually a great website where you can sort of find ecological construction materials. Yeah, there's some interesting little anecdotes here about a family in an underground home in Australia who were able to shelter there during a bushfire. And at the last little sentence here, which I'll read out, says, I hurried them all inside. He's talking about his family. And in calming them down, there was a great deal of comfort and satisfaction in my being able to say to them, there's no need to be afraid. You're inside now. You're safe. You live in one of the safest houses in the world. And I think that's kind of completely the opposite to many of the homes we build these days, as we sort of see again and again, is that houses tend to burn down in a wildfire or bushfire. So I just got a few photos of some underground houses throughout the world. Just did a Google image search, and probably ideas about or thoughts of hobbits and this kind of fantastical creature living under the ground. Of course, lots of animals live underground, and we humans can also do this and sort of benefit from a whole lot of advantages, not the least of which is the bushfire resilience and energy efficiency. Wow. So I like to think of the earth as sort of like this armor that you can put around the home to protect from radiant heat and ember attack. And it's actually a really highly effective and economical type of armor. I mean, if you think about all the things you could armor your house with, like how about ceramic tiles could be used, but that would be very expensive. So like piling earth up around the building and even on the roof just seems like a very economical and ecological way of doing things. And I've already mentioned the energy efficiency, but also when you go into an underground house or an earth-sheltered house, so earth-sheltered is where you just sort of got earth around the building, like in an Earthship. You also get really good sound insulation. And I've also got there like storm resistant. So high winds tend to just sort of like roll over, you know, the top of the building because it's actually quite aerodynamic with the way the earth mounds up to roof level. I've got that blast resistant. Like I actually sort of believe, and I think there's probably examples of these types of buildings being built in like kind of, you know, it's that bunker kind of design or mentality where, again, like if strong wind can just sort of like roll over one of these buildings, then a blast from a bomb can also do this. Yeah, I just think these are just really interesting. And that last note there about really peaceful homes, I guess all these things just kind of add up to create a home that just feels really calming to be inside of, which is probably what the world needs now, is a little bit of calm. So moving right along, this is sort of an excerpt from the Australian Standard for construction of buildings in bushfire prone areas. And I'm just going to sort of go through some of the things that we do here in Australia to try and make our buildings more bushfire resilient. So there's sort of 6 levels that are identified in terms of what's the threat. Is it a low level threat, or this last one here, FZ, stands for flame zone. And that means your house is right very close to some trees, or it could be another building, and therefore if there's a fire, there's going to be flames actually touching your house. So there's a little kind of graphic of it here showing flame zone and yeah, flames all around the building. Whereas if you can get a bit further away from the trees that are on fire, then so BAL or bushfire attack level 40 means that you've got radiant heat of between 29 and 40 kilowatts per meter squared. So if you think of like a meter squared, on that, you know, that's your wall, say, there could be up to 40 kilowatts. And if you think of like a bar heater or something, it might be 1 kilowatt. So imagine 40 bar heaters all on your 1 square meter, which is like 3 feet by 3 feet. That's how much heat energy is expected to go onto your building if you're kind of this close to the trees. And then, of course, the further you get away from the trees, the less heat intensity, the less heat energy on your building. And one of the things, you know, I was talking about the trees. One of the things you do to figure out what your bushfire attack level is you consult the standard, and there's you know, guidance on here, like this is showing the heights of the trees and how densely packed they are. So, you know, if they're 40 meters high and, you know, all bunched together, that's called a tall closed forest. And that's going to be used to figure out what your bushfire attack level is. And so, yeah, a common strategy is to have a defendable area around the building. So here's the building, and this red line with the red cross hatching shows a 20-meter fire buffer zone that's maintained, you know, so it doesn't build up with you know, dropped branches and flammable materials. And also you can see these trees indicated in red, they're actually going to be removed for the construction of this new home to make sure that, you know, that defendable space doesn't have any large trees within it that could catch on fire and put more radiant heat onto the building. So then there's construction details. So whether or not you've got an earth sheltered home, perhaps you've just got a more regular home, there are things you can do to it to make it more bushfire resilient. So this is a list of details from that standard I've been talking about. This is actually from one of my drawings, construction drawings for a new home, that lists all what we need to do to make it, you know, resistant to a BAL 29, bushfire attack level 29 situation. So there's things like the external doors have to have metal hardware, which, when I come to think of it, well, no, I was going to say that would always be the case, but maybe not. These days, a lot of things are often made out of plastic, like maybe handles and things like that could be made out of plastic. It talks about things like draft seals and glazing. So toughened glass is often required. And so that's glass that's been treated so that it's like the glass in your windscreen on your car. Yeah, when it breaks, it doesn't actually, it sort of all holds together. Because, yeah, of course, once a window breaks, the fire can come in and ignite things like furniture and, you know, carpets and things like that. There's also here a list of bushfire resistant timber species. Many of them are eucalypts, or yeah, there's 4 of them are eucalypts. And so, yeah, I'm sure in North America you have a lot of eucalyptus. The Quila or Merbau comes from more tropical climates. And these are timbers that are super dense and hard to you know, set on fire. So these are actually, we're allowed to build with these in Australia in many of these really bad bushfire conditions. And so yeah, here I've just got an image of a this one's kind of Earthship inspired, with a greenhouse or sunroom on that sunny side. But it's actually a straw bale wall construction with a bit of rammed earth. Anyway, up here, where the roof meets the wall, is often a place where embers can get in. And so in this construction drawing, actually, I wonder if I can zoom in easy enough. Yeah, so there's some red lines here, and the red lines are referring to bale mesh or ember guard, which is, well, I've got a photo of that coming up. So yeah, thinking about where embers can get in, because also trying to do ventilation here. This green line is showing airflow through the roof, so we don't get mold growing in the roof. And so being able to let air flow through, but not let embers from a bushfire get in, is part of the game. So products like this, this is like a foam rubber that's been sort of soaked or impregnated with bitumen, and that stops it from burning. And so this one is designed for the corrugated iron roofs, the steel roofing material that's very common in Australia, and you can get different profiles for different, you know, different roof profiles, which might be more common in North America. And like, one of the advantages of these things also keeps out the insects and, you know, rats and mice and things like that. And then there's the ember mesh, which is just a fairly heavy duty fly wire that you might have on your, you know, doors and windows, with a 2mm opening. I guess it's assumed that an ember smaller than 2mm is not going to start a fire. I'm not exactly sure on how they arrived at that size, but that's the industry standard. I'd sort of direct you to, there's a link here, how a bushfire can destroy a home. In Australia, we've got a sort of a forum called The Conversation, where people who do research on all sorts of topics, write in and share their research. And this guy, Douglas Brown, academic at Western Sydney University, has written about how bushfires can destroy a home. So I've got a few of his key points here. So yeah, the weak points are basically the gutters, and this is an example of what not to do. Letting the gutters that collect the roof water fill up with leaves. The roof cavity is a place where, obviously, if you've got a fire starting in here, it can quite easily get into the roof cavity unless you have something like that ember guard sort of neatly detailed in here to stop those embers from getting in. Vents and weep holes, which was that one there. Often walls have vents and weep holes to allow that important air movement to avoid mold and other issues. Subfloors, underneath floors, is a place where fires can get in and set the whole house, set the floor on fire. Even plants and a mulched garden bed close to the home can be problematic, because then if you've got a mulched garden bed right next to your wall, then if that catches on fire, obviously you're then kind of in the flame zone. And yeah, any timber structures. So a lot of homes in Australia have timber decking, out the front, so you can go out and enjoy being outdoors on a timber deck. But it's actually a pretty terrible idea in bushfire-prone areas. And as I've already mentioned, when windows break and the fire gets inside, then that's when it's kind of game over and you're going to lose the house. So yeah, also kind of noting that radiant heat can come from over 200 meters away or 200 yards away. So that's a long way, from the actual fire. That radiant heat travels a long distance. And that can be very dangerous to humans as well. If you think the fire's a long way away, and it is, but the radiant heat will get you. And then, of course, there's the direct flame attack, e.g. from a mulched garden bed right next to the house. So here, when there's an extreme fire risk, here I live in a bushfire-prone area. I do things like I remove curtains from windows, because the curtains can catch on fire from that radiant heat. So any sort of like really flammable things like curtains, or even some types of furniture, you might want to get away from windows. And any outdoor furniture made of timber, I just get that well away from my home. And I'm sort of slowly but surely replacing timber furniture with like things like aluminium or steel furniture. And you might put a cushion on them to make them more comfortable, and then it's relatively easy just to take the cushion inside on a extreme fire risk day. So defense systems, sort of slightly frustrating thing is that we have in the code, the code doesn't make any compensations for sprinkler systems. So you see here, sprinkler systems are kind of beyond the code or standard, but yeah, this standard I've been talking about really focuses on these dot points here. So sealing the gaps, using non-flammable materials, using those bushfire resistant timbers that I showed you, using the correct construction details, putting screens, so putting that bow mesh as a screen on openable windows and doors. And even as you see here in the photo, full-on bushfire shutters that they actually can be quite useful to block out unwanted sun. But if you've designed your house well, these kind of apply mainly to east and west facing windows, where you get the low summer afternoon sun beating into your home and you don't want it, these can be useful too. But yeah, in the flame zone and L40, you're going to need to, you're probably going to need to use something like this to comply with the code. But yeah, I think things like green roofs, earth sheltering, earth bermed walls, and sprinkler systems, they kind of go beyond the code and actually are more, well, I want to say more useful, but I mean, all these things here are good ideas, but this takes it to the next level of resilience. This is a little comparison between Australian and US standards. So we've got Australia and the USA. I just thought it'd be interesting to do this comparison. And I think in Australia, we are more stringent. And maybe that's because historically we have had some pretty horrific fires, but this is not a competition. Yeah, I think yeah, before we started, I heard talk of the gigafire, and yeah, I think I guess the interesting thing about this is that Australia does have some really stringent codes that are nationwide, whereas in America it's a little bit, I think, more state to state with local codes and things like this. So yeah, maybe getting your hands on this Australian bushfire code could be quite instructive if you're building a house in America. So this is an article I wrote for the conversation. There's me down there. And I'll just read this out, this little blurb. It says, recent disastrous bushfires, this was in 2020, have rebooted debate about how to rebuild in the Australian bush. Questions are being asked about building standards, whether a fireproof home is possible, the value of fire bunkers when it's too late to leave, and if we should even live in the bush anymore. This is all the things that were being talked about after the big bushfires in 2020. And so what I wrote in about was basically saying that in bushfire prone areas, we can be much more fire resistant, perhaps even fireproof, by adopting earth covered off grid structures known as earthships. So yeah, I'll talk a little bit more about that as we go. This is a great book that I recommend. As it says there, it could save your life. And it's written by someone who's done lots and lots of research, like going to look at homes that have burnt down and things like that. One thing that sort of struck a chord with me was what are the benefits of making your home a haven, or basically a safe place during a bushfire. So there's no need to travel during danger to reach an evacuation destination. If you think about when there's a bushfire, lots of people are jumping in their cars and trying to quickly escape danger. Often it's smoky, often there's been accidents, often there are trees down on the roads. It's actually not a very safe thing to do. Also, when your home burns down, you're homeless. You got to go figure out where you're going to live for who knows how long, until hopefully the insurance money comes in and you can afford to build a new home. You don't need to abandon your pets. And if you have, prepared your home, done some of these things I've been talking about, you can actually protect your home with confidence and protect all your precious possessions, not the least of which is the home itself, your pets and your lives. And so, yeah, on the flip side, the hazards of not doing this is, of course, you could be at great risk if you're trying to defend your home or shelter in a poorly prepared house. And yeah, as I alluded to in the beginning, if you're trying to escape, then that also can put you at great risk. So yeah, like obviously this is a very serious issue. And so yeah, some of my design work has been aimed fairly and squarely at bushfires. So on my web page, I have a sort of a page about bushfire. There's a link there to my article in the conversation about how earthships are highly bushfire resilient buildings. One of my favorite designs is this sort of little tiny earthship, which was originally intended as a bed and breakfast. It's actually kind of the next version of the earthship I'm in now, which is also a bed and breakfast. But actually, I've had it closed for the last couple of months, and I'm really enjoying using my earthship myself as my home office. Yeah, so this is a neat little design. It's much simpler than my earthship. My earthship's actually got 4 roofs. This one's just got the one ferro cement earth covered roof, so it was super simple to build. We actually have built one of these. So this is the tire wall around here, and then a ferro cement roof goes all the way over, just sort of landing on these 2 side bits. And I'm proposing this as a really bushfire resilient building. And one of the kind of cool concepts I think that earthships have going for them is that greenhouse or sunroom or atrium, whatever you want to call it, where all the plants grow, we talk about that when explaining how earthships work. We refer to that as a thermal buffer zone, where say the heat or the cold from outside is not as extreme in here, and then that's sort of providing this buffer on the temperatures in the living spaces. Well, I want to use that same analogy as a fire buffer zone and propose that you could actually have sprinklers mounted to the roof in here to actually wet that area down, because it's actually sort of already sort of detailed a lot like a wet area. We got plants in here, and we got glass here and here. So if things get a bit wet in there, that could sort of be like a defense against fire coming in through here. If one of these windows does somehow break, and remember, there can be really strong winds associated with bushfires and wildfires. So you can get a burning log just fly into the window and potentially break it. So I sort of have this strange fantasy of being able to sort of lie here in bed with the sprinklers on, with this sort of like rainstorm occurring in the greenhouse, and then beyond that, there's this raging bushfire. Now, maybe that is a complete fantasy, or maybe that is a reality that could be designed into these types of buildings. So yeah, there you see some fire sprinklers mounted to the ceiling in the greenhouse, and then that curve to the roof is from that ferro cement structure, which is covered with earth. And so the ferro cement is inherently, think of it as concrete. It's essentially non-flammable. It won't burn. And then when you put a layer of earth and grass on top of it, then that's even more bushfire resilient. I guess as long as the grass isn't, sort of like dead and, tall. So you want to, well, I'll get to that. I've got a solution for that. So we'll get to that. So yeah, there you see the outside of the building, the rear of the building with more sprinklers up there. This is I call this a gravel gutter. So this is sort of a bed of gravel that actually collects water and directs it into an underground water tank or cistern. So there's no gutter where leaves can collect and catch on fire like in a regular home. There are all the fire sprinklers again. And then another really interesting thing with earthships is the underground cooling tubes underground pipes that bring in the fresh, cool air in the summer. I have one client who's actually tried what I'm about to explain, which is where you get some hessian cloth, drape it over the end of the inlet to the earth tubes. And especially if there's like a nice little source of water nearby, but it could just be a bucket filled with water, the hessian wicks the water out and provides this sort of cool filter membrane so that the air going into the earth tubes has to pass through this wet fabric, and that provides evaporative cooling, and it provides like a smoke filter. And my client told me that this actually worked for her in some really smoky bushfire weather. Her home wasn't threatened, but there was just so much smoke in the air from a nearby fire that this technique really helped improve the indoor air quality. And then, yeah, this is sort of my family-sized earth-covered, earth-sheltered, Earthship design with the green roof. So, you know, typically Earthships are going to have some sort of metal deck roof or even concrete roof or something like that. And I guess this is a little bit like the concrete roof concept, but I've just sort of made it into a green roof, which is where you add a soil layer and you can have some plants growing up there. As I said before, they should be non-flammable, bushfire resilient plants, and I'll come to that. And so, yeah, in this floor plan here, I've even moved the cars in under the roof and the batteries. And I even thought about having like a refuge space. Probably not even necessary because there's so many other defense systems. But the idea is if the fire does get inside somehow past 2 layers of toughened double glazing, you have sort of like a little concrete box in here where you can survive even if the rest of the building burns down. So, but as I said, I think that's probably unnecessary. Here you can see fire shutters. So if we just go back again, yeah, this sort of little structure out here is sort of like a little cowling to hide away the roller shutters that can come down and protect that greenhouse glazing. And then I even thought about how you might protect solar panels with like a flip over shutter, so you can protect the solar panels from the radiant heat and flames. And I just had this vision of being able to come out after the bushfire, you know, flip that open and your solar panels are good to go as well. And it's just like, hey, nothing ever happened here. Like, you know, well, of course something's happened and all the trees are burned around you, but you know, your house is still functional. Yeah, sprinklers in the fire buffer zone. And so now I want to sort of show you, I guess a lot of that was kind of like theoretical. I want to now show you some buildings that are sort of doing what I'm talking about. So this is my Earthship. This is where I'm standing right now, and this is Australia's first council approved Earthship, which sort of has, I guess, demonstrated to people that you can get council approval for an Earthship in Australia. And this was, I don't know, 2013. This was approved. There are my fire sprinklers. There's 2 out protecting the double glazing, and there's 2 on the ridge line, just sort of helping to protect this corrugated iron roof and my solar panels, my solar hot water service. There's the floor plan, the earth tubes or cooling tubes underneath. It's the greenhouse with an earth floor. There you see that bushfire resilient roof, curved ferro cement roof. There it is from the outside with the gravel on top. And to me, that's just like the ultimate bushfire resilient roof. Much better than, yeah, this roof that I've got over the greenhouse. So that's why I've sort of like got rid of that in the latest and greatest design. And it's also made it much more simple to build. There's the bathroom, the beautiful bottle wall. And I think bottle walls would also be very bushfire resilient. They're non-flammable. So yeah, there's construction of the ferro cement roof on my Earthship. Another one there. It's a very bushfire resilient or non-flammable construction. It's essentially concrete. And so this is my reminder to show you a little video I made yesterday.
Earthships are really bushfire resilient because the rear of the building is surrounded by earth. So they're essentially like an underground house. And this particular Earthship, the main roof is a earth covered roof, or it's gravel on top of earth. And so of course that's all very non-flammable. And then to protect other parts of the building, there are little sprinklers up there on the ridgeline. And then if we go around the front of the building, you'll see more sprinklers protecting the double glazed facade. So yeah, there's a sprinkler there and another sprinkler there somewhere. So the idea of that is to keep the glazing cool, and the timber is all bushfire rated timber, so that's a hardwood that is really hard to burn. It's also termite resistant, and the glass is toughened and double glazed, so both layers of glass are toughened. The opening windows have got a flywire, a metal flywire that won't let the embers in. That assumes you're silly enough to have the window open when there's a bushfire. And then, typically Earthships have a cement or lime render, which is also very non-flammable. So I'm just going to go and turn on the firefighting sprinklers, and ideally this can be done by sending a text message to a fancy valve, but this one here labeled fire should do the trick. There goes the pump. This is all powered by the batteries in the Earthship, and there you can see sprinklers. And there's another sprinkler here to protect this end of the building, because the fire will probably come from this direction. So better turn that water off. Done. Safe in a bushfire.
Okay, so hopefully that was a good review of many of the things that I've been talking about so far. You can sort of see some of those things that are required in the code to get approval to build in a bushfire prone area. You can see them in my building. All right, and so this is the next version of that little B&B concept. I call it Earth B&B, and this is it on the cover of a local magazine. There's one of my computer renderings. You've actually seen many of these images before. There's the floor plan again, and there's the finished building. There's a cross section sort of showing a layer of insulation over the ferro cement, and then the earth covering over the insulation. The water tank in the back. A few more photos. You can see things like the cement render on external parts of the building, really bushfire resilient. Greenhouse, bathroom, kitchen. And that's the main room with that vaulted ferro cement roof, earth covered. And there you can see a bushfire resilient roof. And here, this is what I'm proposing for plants. This is a succulent ground cover. So those leaves are full of water. So yeah, little ground covers, things that aren't gonna, like not grasses that are gonna grow tall and need mowing, just like little things that creep across the surface and store water. All right, here's another one in Western Australia. And this one you can see, here's the cross section, the earth berm at the back. This has just got a metal deck roof. But yeah, because of that earth berm or the earth sheltered walls, that is also highly likely to survive a bushfire. There are a few little things, like there's some timber cladding out here. Like it'd be nice to have some fire sprinklers out the front just to keep all that wet. Like wet timber will not burn. So this is where those roof mounted fire sprinklers can be really important. And as I've said already, if you had fire sprinklers in here as well, wow, that would be kind of next level bushfire resilience. You think about commercial buildings, hospitals and universities and things like that. They've almost always got, ceiling mounted sprinklers inside the building. That's how you stop a building from burning down, is by spraying water on things. I don't really know why we don't do it in residential homes. So that's a great shot of the rear of the building with the earth berm and the inlets for the cooling tubes. You'll notice lots and lots of water storage. Of course, that's the other thing, is you need water to fight a fire. So that's another important part of it, is having a good supply of water. And then this is my final example. This one's under construction at the moment. It's actually very similar to the one we just were looking at. It's basically the same design with that metal deck roof. There is a photo of the tire wall under construction. That one shows all the earth tubes at the back and the thermal wrap insulation. And there are the happy owners. And so in conclusion, I think houses can be designed to be far more resilient to bushfires than we're doing already. Clearly, things are not going well with our ability to design homes against bushfires. I think having no gutters, as I've sort of shown you with these earth covered roofs, you can still harvest rainwater, but you don't do it with a gutter. You sort of do it more with gravel filled trenches, which are lined and drained to a water tank. And we've sort of proven that concept now with that one on the screen now down at Wollonga. Minimal exposed surfaces. This is what the earth berming, earth sheltering enables. Is all you really have to do is figure out how to defend that front glazed face of the building. Everything else is surrounded by earth. The bushfire sprinklers seem like a really sensible addition. And then these homes end up being, energy and water efficient, really ecological, and they're beautiful, I think. So my last point there is that our codes in Australia, they're good, but they're also just the minimum standard that we have to achieve to get approval to build. I reckon we can do much better. So that's my last slide. Thanks for listening, everyone. I hope you've learned something. I'm sure I've missed a few things. So if you've spotted something, let's hear about it and we can have a chat. Thank you.
Marty, thank you so much. That was amazing. I have now learned that I live in the worst possible fire zone situation here at Reach.
Oh
Not
no.
only do I have trees 5 feet from my windows, but they're growing up through a wooden deck. Um, so we did get a recent grant to do forest thinning here at the community, which was great from Taos Soil and Water. And so we had some forest thinning. But before we jump into everyone's questions, I want to add something and then ask you something. I guess I can ask you first. Are you, with the sprinklers, are you, when you can, are you catching that water and putting it back in your cistern?
Yeah, in some cases that's possible. Where it falls on that gravel roof, which is above my head, yeah, that goes back into the cistern. So yeah, you can get some recycling of that water. But where it's sort of dumping on the front face of the building out there, it's just sort of like dribbling off into the grass. So yeah, look, I think in your situation, Kirsten, if you had some sprinklers to wet down that deck, that would actually work really well. And part of the key is turning those sprinklers on at the correct time. Like if you do it before the fire comes, you sort of like waste all your water. It's almost like you want the fire to arrive, then you get the water going, and that stops the fire from burning your deck. And then you also want to have some water left over when the fire front passes, so that if there are any little fires that did get started, you can target them with a hose and put them out with a hose, or maybe just your sprinklers will deal with it. But yeah, hopefully that gives you some hope, Kirsten, for making your place defendable.
Yeah, thank you. And then I wanted to add on to your air filtrations, exterior air filtration system in front of the cooling tubes or the vent tubes. Ron built a building where he did a similar thing with plants, kind of wetlands type plants in front of the cooling tube, but also on the inside where there's the door to open or close for the cooling tube, he put a HEPA filter there and then added a tiny, tiny fan. You don't want a super strong draw with those cooling tubes because it's bringing the hot air through too quickly, but it's just a trickle draw. And we've already had instances where there's been fires in the area and it's brought in cleaner air. Or another thing that happens in Taos is a lot of people burn wood fires in the winter and the cold air keeps it compressed. And so it's cleaning that air. And the two other quickly, sorry, everybody, things I want to add, home is haven. The one thing I would add to that is you can help other people when you have built a self-sufficient haven. And so I think we need these nodes of self-sufficiency where your neighbors can come over and, charge their phone and communicate with their loved ones or just be safe there. And then also looking at your small Earth B&B design, do you know the square footage of that building? I mean, you must, but or you probably have square meters.
Yeah. Just typing in convert. Yeah.
Yeah, because I'm thinking
it's 50. It's about 50 square meters. So
that's
I'm gonna
around
say
500
that's
square
about,
feet. I think
say
600,
again?
500 or 600 square feet,
Square
something like that.
feet. No, it's telling me. Oh wait, square meter. Yeah, look, you're probably right, Kirsten. I don't know.
Well, it looks like there's I'm just taking California as an example. They've allowed for ADU accessory dwelling units. Before all the fires, they're starting to allow municipalities are allowing for more people to put a little house in their backyard just to deal with the affordable housing issue. It seems like that design would be a fantastic, instead of like building, rebuilding after a fire and building your full-on house, maybe you could build something, super fire resistant like that on a back part of your lot. first,
Yeah.
perhaps.
Yeah, I think that's good. And yeah, while you're talking, I've got the square meter to square foot. So 50 square meters is 538 square
Yeah.
feet.
Yeah, exactly. So let's quickly breeze through some questions from the chat. We have one of our other instructors from the Mastermind, Lydia Dolman here, and I think you kind of got into this, but she said, I see air vent controls on there on one of your drawings. I'm curious how you're protecting your air ventilation system and if it's the kind of thing where you can shut down the intake, especially when the AQI is terrible. With that ventilation question, I would love to see the roof ventilation plan for the Earthship design.
Yeah. Well, yeah, with the, I mean, on this Earthship, the inlet to the earth tubes, which are outside down the hill, all I've got on them at the moment is some fly wire mesh to stop the snakes and the mosquitoes and the rats. At this end, I've got better control over, like, yes, sort of almost stopping the airflow, reducing it to almost zero. But of course, you always want to have some fresh air coming into the building, so it's not an airtight seal. But in a disaster like a bushfire, I'm planning to just like grab some pillows and like just stuff them in the earth tubes so there's absolutely zero airflow coming through them. And yeah, that idea and like what you said, Kirsten, about the HEPA filter and the little fan, and my idea about the Hessian with the water. I think all these things can kind of evolve. The water and the Hessian could happen here inside the building, or at the other end, or at both ends. Same with the fan and the HEPA filter, like exactly where these components go, and you know that like how they actually work. I feel like I actually don't know. Like sounds like yeah, Ron's done some good prototyping of that. So yeah, it is a bit experimental, but I think the basic theories and principles are all there, and actually they're pretty like ancient ideas. Like cooling systems in the ancient Middle East with their underground cooling tubes and aquifers and all sorts of stuff. Yeah, it's kind of nothing that new. So yeah, I'm not sure if that answered the question too well though. Do you want to just review that one, Kirsten? Is that okay?
The answer to Lydia's question? Yeah, I mean, if
Yeah.
Lydia, let us know if we got that answer. Just throw that in the chat if we covered that. And then Laura is asking, how do you protect the water tanks from melting in the case of a bushfire? And most Earthship water tanks are buried within the berm of the building itself. So it's part of that exterior earthen mound that is unburnable.
Yeah.
Let's see. What do we have?
And if that's not possible, Kirsten, you can build a ferro cement tank or a concrete tank,
Yes.
which are pretty resilient. It's just the plastic poly tanks. Even like in Australia, we have metallic tanks, made out of the corrugated iron roofing material. It gets rolled into a circle. Do you have them in America?
We do. And we've done, tire cisterns with
Yeah.
concrete plaster. And we used to do a lot, which I thought was great, are can cisterns. You have to make sure that you bury them as you build up and reinforce, but just like can wall cisterns and then plastered, which for me is easier to lay, 10 courses of cans than to pound whatever amount of tires that it's going to take. And so, yeah, it's definitely possible to do, unburied fire resistant tanks.
Mhm.
Let's see. We have Vaughn from Australia asking, how sustainable are some of these bushfire resistant materials? Bitumized foam rubber sounds very fire resistant, but like its manufacturer is its end of life and isn't amazing for the environment.
Well, that is a great point, and I think it kind of opens up a whole other discussion about what is a sustainable material. And I don't know, I kind of have developed this attitude that let's use what we need. Hopefully things like that bitumized foam rubber, it's not a massive quantity of material, and the service it provides is it's going to potentially stop the whole house from burning down. So yes, it's not a wonderful, it's a fossil fuel derived petrochemical material. But unfortunately, like a more ecological alternative, I'm not aware of. And I think in future we can look forward to things like, I think mycelium is a really interesting up and coming new, renewable, growable material with very small ecological impacts, if any. And so things like that, like I can imagine a mycelium version of that I could, stuff under my roof to stop the rats and the embers getting in. But at this point in time, I think it's kind of worth the, using those materials. And look, I just like, do you like electricity? Because all your electricity cables are coated in PVC plastic. And, but you just kind of have to use it. There's kind of not a good alternative. So I don't know, that's just one little example. It's like solar panels are fantastic, but they're full of, or not full of, but they contain some very, toxic materials, and like all the mining and processing that has to happen to make solar panels a reality is also not great. So you can see as you go down this rabbit hole, it just gets, I don't know, ickier and ickier and murkier about, like how do you actually, like if we all want to go live in mud huts with no electricity, then yeah, we can kiss goodbye to plastic and, insulated cables and solar panels, but I don't meet too many people who are willing to do that. I don't know. It's a really difficult, it's a great question. And I don't know. I think it's almost mission impossible is what I'm saying. Like, yeah, go live in a mud hut or make some compromises.
Okay, we have a question. Thank you. We have a question from Andrew. Is there a way to make a home fire resilient if it's a timber frame? I am in the Pacific Northwest, so timber is the most abundant local resource, I think.
Well, timber is a wonderful construction material because we can grow it. So, I think timber's great. And obviously one of the downsides, everything has its pros and cons. And one of the things is it can burn. So a lot of the things I've sort of presented today with, like these ideas about how do you keep the embers out of the building, because houses only really burn down when an ember kind of sneaks in, or if you're kind of silly enough to have a huge pile of timber next to your house and that catches on fire, and then your house catches on fire. And so I don't know, it can be tricky in suburbia where you've got one house on fire and that sets the next house on fire just because of that radiant heat is so close. So maybe that's where you think about if it's like clad with timber, sideboards or something, weatherboard, maybe you need to reclad with like a steel cladding, or I don't know, maybe those ideas about using sprinklers just to wet the whole structure down, I think is probably, more logical, rather than like tearing off all your timber cladding and putting up steel cladding. But yeah, a timber framed house should be fine in a bushfire or, you know, any kind of fire that's coming from outside. It's just about how do you keep the fire out, and yeah, I think additionally keeping it wet, because wet timber just won't burn.
And the stuff you were showing for the mesh, Lydia's asking about protecting ventilation in general. We have passive plumbing ventilation, and most of the roof assemblies are vented. As for the roof, we have a product called Vulcan Vent that will seal up under fire-related heat exposure, but most buildings have roof penetrations for plumbing vents. Wait, is that,
Yeah.
yes.
Well, that's true. And I guess the point being made is that they're often plastic pipes. Again, we're back to plastic materials. And one of the downsides, apart from the fossil fuel production system, is that they could melt in a fire. I guess I would say if they did melt, I don't really see that like propagating into the building and starting a fire. Maybe I'm wrong there. I'm not sure. That's a really good question. Maybe you could actually just sort of like using that concept of armor again, you could just armor those plastic pipes with some insulation, like some fiberglass insulation, and then just put a metal sort of covering around that. It could just be like held on with metal cable ties or something like that to try and protect any exposed plastic from radiant heat. And if you're building a new home, you actually don't have to have roof penetrations for waste drain plumbing vents. There's air admittance valves that can let air in. And they can just be put, inside the building in cupboards and things like that. So, but yeah, for existing homes with those roof penetrations, I reckon, yeah, it would kind of be wise to, armor those things with insulation and metal.
Great. And then I guess one follow-up from Lydia. I guess my question is, how are you handling plumbing ventilation in your Earthships? Is it all mechanically vented?
How am I handling what sort of ventilation?
Plumbing ventilation.
Plumbing ventilation. So I think that's referring to the waste drains, isn't it? And so basically when you pull the plug on your bath and the water rushes down the waste drain, it's like the air in the pipe has to go somewhere. So there's usually a vent that goes up through the roof and the air rushes up out of there. But that all just happens without any, pumps or fans or anything like that. It's all just physics. So yeah, no, there's nothing special. My vents, there is one up through the corrugated iron roof, and I guess, to be honest, I haven't really thought about it too much. I think with the sprinklers up there on the roof, so yeah, there's the answer, is the sprinkler is going to stop too much. You see, the cool thing about the sprinklers is that it creates this little, what do you call it, microclimate around the house. So even though it might be, super hot over where the trees are burning, around the house, all these little droplets of water are going to reduce the temperature around the house and, of course, to soak everything down. So if an ember lands on my waste drain pipe, which is unlikely because it's vertical and an ember can't really land on it, yeah, like it's just going to get washed off by the sprinkler water.
Awesome. Marty, thank you so much. Thank you everybody for joining us today. We're going to send you a replay of this in case you want to watch it again. It's going to take us a few days or a little while to get that lightly edited and out to you. And Marty, you are, as always, a wealth, a virtual font of information.
Thank you, Kirsten.
Thank you.
Thank you to you and Jean for all you're doing with this Mastermind education system.
Thanks. Thanks, everybody. Take care. We'll see you on the next one.